NASA says its Explorer 1 test, the most far-off human-made object in the universe, is sending usable data to Earth again. In the universe, we have no thought what it is except for we can gauge it. Explorer 1, the notorious space test sent off by NASA more than 4.5 years prior, has recently conveyed back a message that has sent shockwaves through the academic local area. In the wake of voyaging nearly 14 billion miles from Earth, Explorer 1 has made a revelation so significant that it has adjusted the direction of its main goal, turning around towards our planet. However, what precisely might this disclosure at some point be? Could it be proof of extraterrestrial life, a cosmic abnormality, or something significantly more unfathomable? In this gripping investigation, we'll uncover these stunning disclosures. Explorer 1 has recently made a startling discovery that caused it to abruptly turn around towards Earth. The Explorer twin tests, if certain heavenly events hadn't corresponded, might never have left Earth. For this situation, the aligning stars were the 4 largest planets in our planetary group around 60 years ago. These planets were gradually aligning in a manner that had last happened during Thomas Jefferson's administration in the mid-19th century. This uncommon planetary arrangement went largely unnoticed at first. The primary individual to recognize its significance was Gary Flandreau, a student in aeronautics at the California Institute of Technology. Back in 1965, when space exploration was just beginning, Flandreau was tasked with figuring out the most productive way to send a space test to Jupiter or significantly further away to Saturn, Uranus, or Neptune. Using a simple pencil, he carefully plotted the orbital paths of these giant planets and made a fascinating revelation. In the late 1970s and early 1980s, all 4 planets would align in a way that they could be visited in a single mission. This alignment meant that a rocket would be able to use the gravitational pull of each planet to slingshot itself to the next, significantly reducing travel time. Flandreau determined that this arrangement would cut the flight time from Earth to Neptune from 30 years to just 12 years. However, there was a catch. This planetary arrangement only happened once every 176 years. To exploit this unique opportunity, a spacecraft would have to be launched by the mid-1970s. NASA seized this once-in-a-lifetime chance and built 2 rockets to make the journey. These spacecraft, Explorer 1 and Explorer 2, were sent on an incredible mission to explore the outer planets of our solar system. Due to the alignment of the planets and the visionary calculations of Gary Flandreau, the launch of the Explorer twin tests on September 5, 1977, marked something truly extraordinary occurring at Cape Canaveral in Florida. Explorer 1 embarked on its legendary journey into space, launched by a powerful rocket known as Titan 3E or Centaur. Only 15 days later, Explorer 2 was launched on August 20, 1977. Explorer 1 joined the epic adventure, beginning its journey into the vast universe by following a shorter path. Their primary mission was to explore the massive gas giants in our solar system, like Jupiter and Saturn, along with their numerous moons. However, these fearless space explorers exceeded all expectations. They ventured far beyond, pushing the boundaries of exploration, traveling farther and longer than any other spacecraft in history. They broke numerous records on their inspiring odyssey. They have traveled beyond anything made by humans before, even venturing into a region known as interstellar space, a completely unknown area within our galaxy. These pioneering spacecraft, Explorer 1 and Explorer 2, are now more than 12 billion miles from us. Despite their vast distance, they continue to amaze scientists with the remarkable discoveries they make out there. Most recently, they have made a discovery so unexpected that it has taken everyone by surprise. The Explorer twin tests have achieved some truly remarkable accomplishments. Years ago, they examined the moons of Jupiter and Saturn, which scientists initially believed to be dull and crater-ridden like our moon. These moons turned out to be vibrant centers of activity. Explorer 2 made history by becoming the first of the twins to swing by Uranus in 1986, and just 3 years later, it raced past Neptune, a feat unmatched by any other spacecraft. As these rockets continue their fantastic journey, NASA has used some clever techniques to ensure they remain operational. They've deactivated unnecessary parts like extra components and radiators to conserve power. This strategy aims to keep the spacecraft running smoothly until at least 2030. For the dedicated scientists and engineers who have been part of this extraordinary adventure from its inception, it's a bittersweet mix of emotions. Their hard work has paid off, and just when they thought the Explorer missions were approaching their end, a stunning revelation emerged from the depths of space. Explorers' discovery, data transmission, and revelation in the early days of their epic journey years ago amazed scientists by providing the first up-close views of the moons of Jupiter and Saturn. These moons, which astronomers had believed to be dull and heavily scarred like our own moon, turned out to be dynamic worlds. Explorer 1 reached Jupiter in March 1979, just 546 days after its launch. Explorer 2, following a slightly different path, arrived in July of the same year. Both rockets were equipped with VidCon cameras that used filters to capture full-color images. Interestingly, they were designed to be very stable, rotating through space at a rate more than 10,000 times slower than the hour hand of a clock. This ensured that the images they captured were clear and sharp. During their mission, the explorers took more than 33,000 photos of Jupiter and its moons, each revealing new and intriguing details. For example, Europa, one of Jupiter's 53 named moons, was found to have a cracked, icy crust estimated to be more than 60 m thick. As the spacecraft departed from the Jupiter system, they received a farewell boost in speed of 35,700 miles per hour from a gravitational slingshot, a crucial maneuver that helped propel them towards interstellar space. At Saturn, the explorers went their separate ways. Explorer 1 passed through Saturn's majestic rings, enduring thousands of impacts from tiny dust particles before flying by Titan, a moon shrouded in an orange haze, and traveling northward out of the plane of the planets. Explorer 2 continued its solitary journey, reaching Uranus and Neptune in 1986. During its visit to Uranus, Explorer 2 discovered 10 new moons and added the planet to the list of worlds in our solar system with rings. However, Explorer 2's accomplishments were overshadowed by tragedy. Just 4 days after its closest approach to Uranus, the Space Shuttle Challenger tragically exploded shortly after takeoff, claiming the lives of all 7 crew members, including Krista McAuliffe, a high school teacher from New Hampshire who was set to become the first civilian to travel into space. 3 years later, as Explorer 2 soared around 2,800 miles above Neptune's striking blue methane sky, it encountered the swiftest winds recorded on any planet in our solar system, reaching speeds of up to 1,000 miles per hour. Neptune's largest moon, Triton, turned out to be one of the coldest places in our vast neighborhood, with surface temperatures dropping to a staggering minus 235 degrees Celsius. The moon's icy volcanoes were another remarkable find, spewing nitrogen gas and fine particles up to 5 miles into its atmosphere. After Explorer 2's captivating images of Neptune and its moons, both spacecraft were scheduled to shut down their cameras, marking the end of their official mission. However, astronomer Carl Sagan, a member of the mission's imaging team, intervened. Despite the official mission ending, NASA had extended the mission with hopes that the Voyagers would venture into interstellar space. Renamed the Explorer Interstellar Mission, the spacecraft were set to continue their journey into the unknown. Sagan convinced NASA to let Explorer 1 take one last series of pictures on Valentine's Day in 1990. The spacecraft turned its cameras back toward the inner solar system and snapped 60 final shots. One of these images, famously referred to by Carl Sagan as the pale blue dot, captured Earth from a staggering distance of 3.8 billion miles. In the picture, Earth appears as a tiny speck, barely visible against the vastness of space, illuminated by a faint glow of sunlight bounced off the camera's optics. We've learned so much about the planets and moons in our solar system. It's exciting to see how unique and intriguing each one is, even those that are farthest away. Explorer's journey beyond the heliosphere in August 2012 marked an incredible achievement. By venturing beyond the heliosphere, a vast region of charged particles emitted by the Sun, Explorer 1's remarkable feat became widely known the following year when a study was published in the journal Science. Sharing Explorer's groundbreaking discovery, the spacecraft's plasma wave instrument detected a powerful solar eruption between April 9th and May 22, 2013. This event caused electrons near Explorer 1 to vibrate, indicating that the spacecraft had entered a region of higher particle density than that found right inside the heliosphere. At first glance, it might seem surprising that the electron density is greater in interstellar space than near the Sun. However, researchers explained that the electron density at the heliosphere's edge is significantly lower than at Earth's surface. Analyzing Explorer 1's data, researchers pinpointed the official flight date as August 25, 2012. This determination was not based solely on electron oscillations, but also on measurements of charged solar particles gathered by the spacecraft on that crucial day. Incidentally, this was also the day that the renowned Apollo 11 astronaut Neil Armstrong passed away. On this pivotal date, Explorer 1 detected a remarkable thousand-fold decrease in solar particles.